We're going to do a unique demonstration that's never been done before publicly, so it's pretty cool what we're going to do. One of the things we take a lot of pride in at HammerHead, and some of you have been to the WWETT show many, many times and have experienced HammerHead. Some of you, this might be the first time you've ever seen HammerHead at the WWETT show. So let us give you a little taste of who we are here at HammerHead.
HammerHead Trenchless manufactures a combination of pipe rehabilitation and replacement equipment and solutions for the underground construction market. HammerHead offers a broad range of solutions that solve today's underground infrastructure challenges while reducing the environmental and social impact of construction. HammerHead University is a comprehensive training program that is setting a new standard in education for trenchless and underground construction professionals. Our state-of-the-art training center provides a controlled learning environment that simulates real-life applications of HammerHead products, while allowing students to concentrate on mastering the process involved to ensure they are successful on every job. For innovative pipe rehabilitation and replacement solutions and unmatched support, underground construction pros trust HammerHead Trenchless.
You know, that's just a taste of who we are. That's what you see up front. There's a lot that goes on in the background. I mean, you saw a little bit about what the products are, and that's one piece of HammerHead. That service element's another big side. That training that we have at the university, we also have online training as well, because we want to create things for our users and customers that are repeatable, scalable, and sustainable every single time. But the thing you don't see is what we do on the backside, which is quality reassurance, testing time and time again. And that's what our engineering team does at HammerHead. And today I've got Steve Warchowski and Dave Kosman with our engineering team. And Dave, what are we looking at here? This is pretty different. I've never seen this at a trade show.
Jeff, this is what we call a pressure validation apparatus. So as anybody knows, when you're dealing with a piping system, whether it's above ground or buried, if it's a gravity pipe or a pressure pipe, it's subjected to design loads. And those it could be external loads or internal pressures. And external loads could be in the form of soil loading, groundwater pressures, live loads, etc. In terms of internal pressures, you could see a sustained pressure from like a water main or a fire main or even a force main. Cyclical loads where the pumps start and stop. It could have negative pressures and vacuum. Well, you have design concepts obviously that lead to what the recommendations are for that piping system or lining system. And then you have to validate that through testing. And that's what we're doing here through validation testing. What we have here is a 6-inch diameter pressure pipe. It is a reinforced CIPP system with epoxy resin designed for a variety of different applications. Could be a sewer force main, could be a raw water main, a potable water application, or a fire main. So, go ahead, John.
So what are they going to see? We're gonna rupture this pipe? Is that what we're talking about?
We're going to take it to failure. We're going to take it to failure. You must have a better microphone than I do. So.
Yes, I do.
Okay. Or you speak louder.
I speak much louder.
Okay. At any rate, so we're going to take this to failure. Basically, this is a prescriptive. I'm going to change microphones. This is a prescriptive test. This is actually following an ASTM standard called ASTM D1599. And many of you are involved in the pressure pipe market understand that there's a way of determining what your pressure rating is through different types of testing. And this is one specific test that's used in that regard. And this is a 6-inch diameter pipe, which obviously we've made it ballistic proof through our engineers in-house.
So no one has to worry about anything is what we were saying here, Cass.
That's correct.
Okay.
So what you're going to see this material actually physically burst. And when it does, you're going to see a splash of water. And we are going to collect that water, recycle it, reuse it. This sample is unrestrained from end to end, from the points between the couplings. So inside this, we have a tie rod. And on either end, we have end plates that are sealed internally with a seal that is inflated up against the CIPP and then restrained outside with these couplings. What we're trying to do is we are going to pressurize this system, again, at a steady rate over a short period of time until it reaches failure. And depending on the type of material you're dealing with, whether it's a thermoplastic or a thermosetting material, in this case, this is a reinforced thermoset, again, with epoxy resin. you're going to see a physical burst. So it's going to be a pop. It's going to be a punch through type burst. You could see materials that will have a linear failure, or it could be in a spot, or it could be a weep. But in this case, it's going to be a physical burst. So
let's do this.
Let's do that. And just so you know, we have the ability to test not just 6-inch, but up to 24-inch in diameter.
So, Kaz, you talk us through what's going to be up on the screen for everyone to see. And Steve, let's do it.
So we have fully automated this, and you can actually run this manually if you want to as well. So you can see this through computer controls. You're going to see a time versus pressure plot. So as we build up pressure, we fill this with water and evacuated all the air so we don't get that spike. Eventually you're going to see it start to climb.
So that pressure's starting to go up. You can see it on the graph right there, right? Is that what we're looking at?
That's it.
So that's growing pressure inside this CIPP liner, and you see it's going up pretty good. You're at over, what is that, 150, 160 PSI?
Doing a steady climb.
What's that liner rated for?
This is actually an R&D liner, so this one is about 500-600 PSI roughly in terms of burst pressure, which translates to about 125 to 150 PSI pressure. It's a 4-to-1 ratio.
So we're going to start hearing cracking or something eventually,
That's
guys?
it. If you start cracking, you're going to see a physical burst.
I hear cracking. Wow.
So there you go.
So at this point, you would have this information, Dave, and we can validate the quality of our liners if they meet the design standard or things of that nature, correct?
That's correct. And as a basis of design, you use this to determine what your estimated pressure ratings are for your material. And then in the field, if you want to confirm that, you can capture full samples and do what we call a split ring test, and it's an ASTM D2290 test. You're basically taking the full hoop and you're pulling tension on basically a cylindrical piece that's split in the middle, pulling tension to failure. That gives you a very comparable, actually almost identical performance. If you look at the geometry of this versus the geometry of the sample you test in a lab, you're going to have virtually identical performance. And that confirms your design and performance of the material.
Perfect.
So one other thing I want to say here too is this isn't the only test that can be done. You can run a variety of different test parameters. You can do ramp and hold at positive pressure up to a certain level and hold it for a duration of time, or a negative pressure at a certain period, for a certain level. Let's say you want to test to -7 PSI or a full vacuum. You can do that. You can do cyclical testing, and this is rated up to 1500 PSI. So think about that. You can burst test samples up to 1500 PSI internally.
Cool stuff. Well, listen, if you're interested in learning more about this, Steve and Dave are up here, or anything else from HammerHead, grab someone in a gray black shirt today, and we'd be happy to educate you and walk you through some of the different products that are found here at HammerHead. Thank you for joining us. There will be a blue light demonstration in 1100 in roughly an hour. We'll be doing this afternoon. Thank you.